Now, for this example, a couple things you have to know. First off, when we're talking direction, north is up here, and then it goes east, south, west. North is 0 degrees, and then it goes in a clockwise direction. So the cardinal directions are like this: 0, 90, 180, 270. When it says that we have an airplane flying at 200 miles per hour at a southeast bearing of 140 degrees, well, there's north, southeast, it's like this, and it's 200 miles per hour. I'm making my vector 200, but the angle is 140. It's right there. That's where the 140 is. And then at the same time, there's a wind blowing on it. Now it's a south wind, a north wind, so it's blowing from north to south. So north is here, but it's blowing straight south. I'm going to put this in purple, like this, 16.2. And that's all the way around here. That's at 180 degrees. And what I want to know is what this would appear to happen from the ground. So that's the resultant vector of adding these two together, the black one and the purple one. And the resultant vector is what I'm putting in here in red. So what I want to find is that resultant vector. I want to find the magnitude of it, and I want to find the direction of it. So I'm going to start by finding the magnitude. And I'm going to do that by using this angle right here. This angle and this angle, they're the same because they are parallel. So this is 140 degrees also. And now that I know that that's 140, and I want to find this length right here, that's a triangle. I can use anything we've learned up to this point in time. And what I'm going to do is I'm going to use the law of cosines. And I'm going to use x squared is equal to, and I'm going to go with 200 squared plus 16.2 squared, and just use all of that and plug that in and use the law of cosines. It's easiest to do that way, less kind of work. It's something we already know and I've already worked with. And I punch it into my calculator, and I get 212.67 miles per hour. Then the last part of this is to find the angle that it's traveling at. Now the angle that we're looking for is the whole angle all the way around. I already know that part of that's 140, but I need to figure out what this is right here. I'll call that angle gamma. And I'm going to find that. And again, now that I've got the 212.67, I'm going to go ahead and use that law of cosines again. And plug everything in at 16.2 on the left side this time. And just plug everything in, solve, and move everything around like we have, and I get 2.8 degrees for that gamma. So that means that my final answer here is it's 212 degrees, or 212.67 miles per hour at not 2.8 degrees, but 2.8 plus the 140. So 142.8 degree southeast.